We defined polar coordinates and saw how multiple representations of a point can occur. Now what we're going to do is convert polar points to rectangular points and vice versa, and also convert equations. So you're going to have 4 conversion formulas. So first let's take a look at what if you want to go from a polar point to a rectangular point. Very quite simple to explain actually. So say we're looking at a point in quadrant 1. And say that this point was r comma theta. So remember that r is the distance from the origin or the pole, and theta is the angle away from the polar axis, which is the positive x-axis. Now that's in polar form. In rectangular form, x represents the distance you went left or right, and y represents the distance that you went up and down. And the y and x create a right triangle. So because we have a right triangle, we're going to be able to use SOHCAHTOA. So remember, you have the black and you're trying to get to the green and the orange. So the first one I can do is look at x. So because I have theta and I have the hypotenuse of the right triangle, x is the adjacent, so I'm going to use cosine. So I have cosine of theta is the adjacent over the hypotenuse. And then when I bring r over, I'm going to put it to the left side here. X is equal to r cosine theta. So that's one of my conversion formulas. For y, because it's opposite, I'm going to use sine. So I have sine theta is y over r. And when I bring the r over, I get y is equal to r sine theta. So here's my first 2 conversion formulas. If I have r and theta, I can get x and y. So let's do one example of that. So I want to convert the polar point to rectangular. So this is r and this is theta. So I have x is equal to r cosine theta, which means that it's equal to 6 cosine of 5 pi over 6. And I have y is equal to r sine theta, which is equal to 6 sine of 5 pi over 6. So now we evaluate the angles. So 5 pi over 6 is in quadrant 2, which makes cosine negative. It has a reference angle of pi over 6, so negative radical 3 over 2. And for sine, similarly, you get a positive 1/2. So when I simplify that, I get negative 3, radical 3, and 3. So in rectangular form, my point is negative square root of 3 over 3. So what would happen is, if I graphed it in polar or if I graphed it in rectangular, if it was to the same scale, the point would be exactly at the same space. It's just that you're writing them in different coordinate system. So here it is. Okay, now what about if we want to convert the other way? What if we have x and y and we want to get r and theta? Well, we begin by doing a very similar drawing, but now the point is x comma y. So remember, x is the distance you went left and right, y is the distance you went up and down. And now we're looking for r, the distance from the origin, and theta. But again, it's a right triangle. So I have the black, I have x and y. I'm looking for r. Well, r is the hypotenuse of a right triangle, so I can use the Pythagorean theorem. So r squared is equal to x squared plus y squared. Done. And then I'm looking for theta, and I have y and x, which is opposite and adjacent, so I'm going to use tangent. So I have the tangent of theta is equal to y over x. And here are my other 2 conversion formulas. So the 2 at the top and the 2 here makes my 4 conversion formulas. So let's convert to polar. And this one is a little bit trickier than converting to rectangular. So I have 3 different examples. So this is x and this is y. I would highly advise writing that just until you kind of get used to your conversion formulas. So r is easier to find. So r squared is equal to negative 3 squared plus 3 squared. 9 plus 9, 18. So r is equal to the square root of 18. But because r is 9 times 2, this is 3 radical 2. Then I have the tangent of theta is 3 over negative 3, y over x, which means that it's negative 1. And this is the part that's a bit tricky, because remember that tangent is negative 1 infinite amount of times. And it's negative 1 in quadrant 2 and quadrant 4. So how do you know what quadrant you need to find the angle? You look at the original point. So the original point is negative 3 comma 3, so it would be somewhere right here. So you are in quadrant 2. Very important. We've talked about in the past how people really tend to forget about quadrants. You really have to think about your quadrants. So I am in quadrant 2. So the angle that makes tangent -1 in quadrant 2 is 3 pi over 4. So this is 3 radical 2, 3 pi over 4. So here's my point in polar. Same point, just different way of writing it. Let's do another one. This is x, this is y. So I have r squared is equal to -2 squared, positive 2 squared, plus -2 square root of 3 squared, 4 plus, here I'm going to distribute the squared, so -2 squared is 4, square root of 3 squared is 3. This is 4 plus 12, which is 16, which means that r is 4. Don't forget to square root, right? That's r squared, not r. Then I have the tangent of theta is a y over x, which simplifies to negative square root of 3. Now, when x is positive and y is negative, that puts me in quadrant 4. Now, the only way I'm going to get that tangent is negative square root of 3 in quadrant 4 is that sine is negative radical 3 over 2 and cosine is 1/2. So the angle that makes that true is 5 pi over 3. So my point is 4, 5 pi over 3. And there it is. One more. This is x, this is y. R squared is equal to 0 squared plus -2 squared. This is 0 plus 4, which means that r is 2. Then I have the tangent of theta is equal to -2 over 0. Well, this is bad, and this is why I want to give an example of this. Remember that anytime x or y is 0, it's going to be on an axis. So when one of them is 0, what you're going to do to find the angle is you're just going to plot it. So this is 0, -2. And then this is the axis angle 3 pi over 2, 270 degrees. So when one of them is 0, now you can look at just what axis angle it is. So 2, 3 pi over 2. Perfect. Now you can also convert equations, not just points. So what I'm going to do here is I'm going to write my conversions formula. So x cosine theta, y is equal to r sine theta, r squared is equal to x squared plus y squared. And sometimes you'll use 1, sometimes you'll use 2 or 3, okay, it will just depend. So anytime you're converting, if you're going to polar, you can see the equation currently has x's and y's. I can now have no more x's and y's. I have to convert everything to r's and thetas. So the first thing I notice is that x squared plus y squared is r squared. So I can change x squared plus y squared into r squared. The next thing I notice is that x, which is right here, x is r cosine theta. So I can replace it as 3r cosine theta. Then here the r's cancel because there's 2 on the left and 1 on the right. So it reduces to r is equal to 3 cosine theta. Now, in rectangular form, when x and y's are both being squared, this is a circle. So we are actually going to graph in the future videos how to graph the circle in polar form. So how you're going to graph r is equal to 3 cosine theta. Now let's take a look at the other one. So now we're going from polar to rectangular. So we have theta, but we want it in terms of x's and y's, or just x or just y's, but no r's, no thetas. So what I notice is that my equation, theta equals 5 pi over 3, only has a theta in it. And if I take a look at my conversion formulas, the only one out of the 4 that only has theta is the last one. So I'm going to utilize this. Now, my theta in my conversion formula has tangent. And very luckily for us, if we can do something to one side of the equation as long as we do it to the other. So I'm going to tangent both sides. And now I can change tangent theta into y over x. And I can evaluate the tangent of 5 pi over 3. So 5 pi over 3 is in quadrant 4. It has a reference angle of pi over 3. So that's going to be a negative square root of 3 over 2 over a positive 1/2, which is going to give me y over x is equal to negative square root of 3. And then I'm going to bring the x over. Now in rectangular form, when the y's and x are both to the power of 1, this is called a linear equation. It is a line. So actually, theta equals is going to be a line. And again, you'll see this when we graph later in the later videos. We're going to be graphing in polar.